title is exactly what can I say about that? Nothing, really. I'm not an artist. I have not grown up in the family of artists, rather civil engineers. So maybe at the best, some technical drawings, not artist approaches. So, but I wanted to share some stories and a little bit related everything to this building and how we have progressed with this building. So you know that when we got decisions to build IT building to extend the Computer Science Institute, we needed space. There were architects competing, a competition. Out of the 6 works, this was chosen. So now we have this building. In the beginning, it's on the drawing board. And architects named the competition as Iconicum. It has to be iconic for Tartu. So in their mind, giving any other name to this building would be bad. And this is the list of names that was proposed through the naming competition. We have the architecture, and we have the names from the competition. And now somebody has to choose. How do you choose? Or reject all of them? I don't know if you can read them, but this list has not been presented in public, I think, at all. There are many Greek letters. Unfortunately, Omicron is not one of them. But sigmas and betas there. I think Armas was popular, Numericum, different names. But then out of these, you start shortlisting maybe something that it could be. It could be beta building, no alphas. But once you fix, or pi up right in the corner, I think sigma is somewhere. So one of the reasons for delta was the architects gave the shape. And it had this feeling that in all the languages it's the same. The name is used a lot in the world, but this was the basis. And then interior design and all the graphical design started, and this is the Bureau Velvet, who started from the idea that this is the architecture. There is a name, and in the name justification we said that actually the shape of the architecture resembles the capital letter delta in Greek alphabet. And then they started this design process that there has to be this focusing and distribution, river delta, a river flows into different branches, delta, and that's how they presented, how they came back with this symbol for interior design purposes for delta. So this is how they got into this thought process, what is extensively used in delta. You see this is the design, original design, the doors design, and we have this delta symbol consisting of triangles, big deltas. We had different ideas that universities do research in collaboration with the companies and state, this what is known as triple helix concept, but we can do this in the triangular shape as well. And now we are using this in the doors, glasses, air rings in the shape of this delta symbol. Is it fixed brand? And that's where Kärt comes in. Kärt was at the time, for 1 year, what is this officially English term, the professor of free arts, liberal arts, professor of liberal arts. And her period overlapped with the opening of Delta 2 years ago. And the idea was that there has to be some gaming related to this. It can't be a static symbol. staying as it is. So that is one of the key aspects, that it has to start its own life in some way or the other. And then Kärt started to propose different ideas, different shapes. Some of those you see in this invitation to this in this day. And we somehow said that this kind of thing has potential, but something is missing. The big picture is missing. So I stepped in, that took my PowerPoint skills and draw some lines that there has to be something bigger around this. And that's when Kärt came back with this freehand form graphical thing, and now we have started to use these symbols in here. But this is the creativity process, that you propose different ideas, somebody helps to, okay, this idea we like to work with, and you move on in that direction. Now there is going to be a huge leap to my algorithmics courses, where I teach algorithms, optimization, evolution. There are some ecologists, evolutionary biologists in here. I was doing these evolutionary algorithms, and by Googling found this book from, I think, late 1990s that talks about evolutionary design by computers. So what is the principle in here is that these forms can be created, designed by a formula, mathematical formula expressing some shapes. And like the Kärt proposed different ideas, and we help to kind of navigate that space. The idea is that computer generates all these shapes that are somewhat related. With a very low mutation, the center is always, there are 4 unique centers, right? So the center is the starting concept, and around there is evolutionary small changes in one way or the other. Very stable, slow mutation rate on the top left, and faster mutation rates to the bottom right. You see how much the shape changes by changing some mathematical formula. And the concept is that rather than environment in biology giving how fit the individual is in that environment, it's some eye of the artist who says which direction seems the most plausible, right, or most interesting. So that all that the artist would do in this case is, okay, out of the 8 proposals, I choose this one as a new starting point. And then you again get 8 proposals around, select another one. So kind of working a little bit in the similar fashion as we did this process with Kärt. So this is entirely a mathematical process, but evaluation function fitness comes not from the mathematics, but from the artistic viewpoint. And then all kinds of weird creatures can be created in this principle. You can see another example is snowflakes. Every snowflake is different, but guess what? They can be designed with a very few parameters that kind of simulate the growth. On the bottom right, you see that there are some 7, 8 parameters that kind of give the rise to the specific variant of that snowflake. You change them a little bit, it will be different snowflake. So mathematics and art in the forms of snowflakes, these are borrowed from the internet, can be combined. Yeah? So another example, we teach, remember, evolutionary algorithms for optimization. Evolution is optimizing us to the environment, and the evolution in here is driving computer to simulate Mona Lisa as good as possible with, on the right, with circles, I think 100 circles. Draw Mona Lisa with 100 circles, with a little bit of transparency in the color. On the left, draw Mona Lisa with 50 rectangles with a transparent color. So that is a task to the computer, and computer can optimize what could be one of the best ways to simulate, because you know the fitness, you know The most fit is the image that is exactly the Mona Lisa. So you try to minimize the difference from the original Mona Lisa. Is this art? No, but this helps to teach this optimization process. Another example, strings. And in the algorithmics course, the guys in the master's program took this as the basis and how to make this art out of this form of strings. And this is the in silico, in computation, virtual world string-based art, where you just thread this one string through the pins on the edges. Again, optimization task in there. But you could say that this is getting closer to some art. From algorithms, you get to this. So there has to be something. It kind of seems to be quite useful process. Another example that we have in the third floor is this magic mirror that takes the painting and makes the video output in the same style. So this is a style transfer to the video feed done by these kinds of deep neural networks. Again, using art in education projects that try to optimize both things together, similarity to the original video feed or photo, one photo at a time, and similarity to the painting by the style. Again, optimization process delivers this. And then, of course, more naturally, computer games, computer graphics, from the computer graphics and virtual reality lab, where the students are taught how to do the ray tracing, 3D image generation, basically creating all kinds of computer games, all the rendering in there, mathematics plus artistry combined. And of course the question is how much the particular student has this artistic touch and feel versus technical engineering approach, and how to combine these together, how to give some rise to some stylistic approaches in there. The last piece of news I want to carry is that the text is fake, but we start to produce now master's thesis in the way that next to the abstract as text that you don't want to read, you don't want to, actually they are not related to each other. I just put there are two abstracts, one text and the other visual abstract. So the concept is let's visualize what they do in their master's thesis. So this particular one, you can start reading that. Okay, we take health data, we look for individual paths of individuals until they die at the end, then develop Markov model, try to analyze these typical pathways, Markov models, and share these results back to the healthcare or financial assessment. That's the summary of the research work. Much easier to read. This is a little bit too much details, but visually kind of says machine learning from data methods results written work. He threw in the word cloud, part of his creativity and the approach. The next one, you see, start from the XML and produce sound. So this is the power of this kind of visualizing what is being done in their thesis. Students take 15 minutes, 12, 15 minutes to present that in the defense committee, but in here I can say in one sentence what they did without reading the text. That is the power of this visualization. Or creativity, again, health data, machine learning, lasso regression, random forest, AdaBoost or whatever machine learning algorithms, so they came back with a visualization of these ideas. So without having the text, we see through the visualization what they have been doing in the research. So I just borrowed them. We will get this first batch of data science students to graduate in a couple of weeks' time from now. Anna Alenaki, who was managing this, her photo from the photo contest, combining transformers, another type of deep learning neural network architectures for music, and these compute platforms that we have. Our computers are not enough. A couple of weeks from now, Lumi supercomputer is going to be opened in Kajaani, North Finland, so it is part of that supercomputer generation. So all our researchers from Estonia and businesses can get access to this supercomputer that at the time of design should have been 5th fastest in the world. So there is enough power for deep learning, machine learning, and hopefully there will be some stylistic architecture, whatever creativity involved. There is a lot of engineering and creativity in order to make these cars autonomously self-drive, right? So this is something where when I came to university, started to study mathematics and computer science, all the other disciplines kind of, oh, this is boring, this is still improving or something. Actually, in these things, everything is up to imagination, everything is up to creativity. How do you do stuff in the virtual world that is not physical? And that's where mathematics, computer science, art come together. Thank you for listening. I'm open for questions.